Okay, today we're gonna start with sigma algebra. Sigma algebra. So if we have any set, let X be a set, and we have the collection. Let S be the collection of subsets of X. Then we say that S is called a sigma algebra if the first property says that the empty set should belong to the set S. Second property says that if E belong to set S, then the complement should also belong to the set S. And third says if we have countable many sets, then the union of all those countable sets should belong to the set S. This is sigma algebra. So example, if we take the example, the very easy example, so we can just make. So example is if we have let X is equal to set of real number, and we just define this. So is a sigma algebra. Is a sigma algebra. Okay. And the second example, again, if we take the same set R, but we define our set S2 is the empty set, and then we consider definitely the set of real number, and we take the interval 0 1, and then we consider the complement of that 0 1 interval, closed interval. So is a sigma algebra. Is a sigma algebra. Clearly, okay, because it satisfies the condition, all three properties are condition. So next we are gonna discuss a theorem. Okay, theorem is a sigma algebra is closed under countable intersection. Okay, so proof. So how can we prove that if we have any sigma algebra S, then to show that it is closed under countable intersection, so we say that let we have countable many sets in the sigma algebra S. What we need to show? We need to show that the intersection of k is equal to 1 up to infinity e k belong to S. So how can we show that? So we already assume that e1, e2, ek they all belong to the set S. So by the second property, if e1 belong to S, then the complement also belong to S. So definitely, like if e2 belong to S, then the complement of that set also belong to the set S. So like if we have many sets, like definitely the complement will belong to S. Okay, so up to, like we say that up to so on, if we have any set ek belong to S, then the complement of ek also belong to S. Now the third property says that the union of all those actually belong the union of all those, okay, belong to the set S. Now again the second property says that if we have any element belong to the sigma algebra, the complement should belong to also sigma algebra. So what is the complement of that set? K is equal to 1 up to infinity x e k. This also belong to S. Now by De Morgan law, what it is? De Morgan law. It is nothing but it is actually the intersection of k is equal to 1 up to infinity e k belong to S, and that was our goal. Okay, so our goal was to prove. So we just use the property second and third of the definition. Okay, that if we have any set e1 e2 up to so on, this means the complement of e1 complement of e2 up to so on will belong to the set S. And then by the third property, if we have countable sets, the union will also. So if the complement e1 complement e2 complement e3 belong to S, then the union also belong to the S. And then again we use the second property that okay, if we have any set S, now this union is any set S, so the complement is also will be in the sigma algebra. So if we take the complement of this set, it is nothing but this thing by De Morgan law. So we already proved that. Okay, and I think that's it. But before actually closing this session, I'm gonna give you a exercise. So for exercise, you can prove it if we have let I belong to I be the family of sigma algebras. Sigma algebra. Then show that intersection of I belong to I, although sigma algebra is again a sigma algebra. Okay, so this is exercise, you can easily prove it. So it is this, it says that the intersection of sigma algebras is again a sigma algebra.